All right, adding and subtracting rational expressions. Key concepts: a rational expression is a fraction where the numerator and denominator is a polynomial. The denominators must be the same. To add or subtract rational expressions, the denominators must be the same, and if the denominators differ, you must find a common denominator. Steps for adding and subtracting rational expressions with like denominators. When the denominators are already the same, we just have to add or subtract the numerators. So, for example, 3 over x plus 2 plus 5 over x plus 2. The denominators are the same. They both have a denominator of x plus 2. So we can just add the numerators. That would be 8 over x plus 2. All right, same concept as if you were adding fractions. If we had 3 halves plus 4 halves, that would be 7 halves, right? Simplify the result. So when we get our final answer, all right, we want to look to see if we can factor and simplify, okay? When we get our final answer, we want to look to see if we can factor and simplify. So, for example, if we had a final answer after we had added or subtracted two rational expressions, if our answer was x squared plus 3x over x, what would we have as a GCF in the numerator? X. We could take out an x, which would leave us with x plus 3 over x, and then we could cancel out those x's, which would mean our answer would just be x plus 3. All right, so go ahead and try and do these practice problems here, and we'll go over them. All right, so number 1, that would just be 11 over y minus 3. Number 2, that'd be 4 over x plus 5. Number 3, that would be 5x plus 5 over x plus 1. Is there a GCF in the numerator? 5. So it'd give you 5 times x plus 1 over x plus 1. So the x plus 1s would cancel, which means that answer is just 5. Steps for adding and subtracting rational expressions with unlike denominators. So this first example right here, our denominators are x plus 2 and x minus 1. So our least common denominator would be x plus 2 times x minus 1. So what we would do is the first term, we would multiply the numerator and the denominator by x minus 1 to get the same denominator. The second term, we would multiply the numerator and denominator by x plus 2. And the numerators we would need to distribute. So I'd have 3x minus 3 over our LCD plus 4x plus 8 over our LCD. And then from there, now that we have the same denominator, we could add and combine like terms. So that would give us 7x plus 5. And there's no GCF there, so that would be our solution. All right. Adding and subtracting rational expressions with factored denominators. So this first example here, we need to factor the denominator in the first term. What's x squared minus 9?
X plus 3x minus 3.
Good. So that means we need to multiply the second term by x plus 3. And then we would have the same denominator. We would need to distribute the 5. Should give us 3 plus 5x plus 15 over x minus 3, x plus 3. Which means our solution would be 5x plus 18 over x minus 3, x plus 3. All right. Example 2. All right, what would be the factor of the first denominator?
X plus 2, x plus 0.
It would be, what's the GCF there? X. So you do with x plus 2. So what would we need to multiply the second term by? X plus 2. Good. Thank you. So, I'm going to rewrite that. I need to distribute the 3. Okay, gives me 3x plus 6. Now here, this is where a common mistake is, okay? Since we're doing subtraction, and we're subtracting a binomial, okay? We want to distribute that negative to help prevent mistakes, okay? So we'll make it one term. We'll distribute that negative, and we'll have 4 minus 3x minus 6 over x times x plus 2, okay? Just like when we're adding and just like when we're subtracting polynomials, distribute that negative and combine like terms to help prevent mistakes. So that'll give us negative 2 minus 3x over x times x plus 2. All right, next. Steps to simplify a compound fraction. So here with a compound fraction, we are going to do what we just did in the numerator and then the denominator, and then we'll keep change flip. We'll multiply by the reciprocal, okay? So first we need to take the numerator, 2 over x plus 3 over y, and we need to get common denominator and add them together. So what do you think the common denominator would be on the numerator? xy, good. So the first term in the numerator, need to multiply the numerator and denominator by y. The right side, multiply the numerator and denominator by x. All right, I kind of get, as we go on this, I kind of get off the blanks because I just didn't like them. So this will give me 2y over xy plus 3x over xy, which would be 2y plus 3x over xy. Okay. So for the denominator, 1 over x minus 4 over y, what's the common denominator going to be? xy. So multiply the left side by y, right side by x, and that will give me y minus 4x over xy. So this is where I get off the spaces. Because it's set up like this, I went ahead and put in the division bar there. All right, that would be the division bar. And from there, we would keep, change, flip. So we'll have 2y plus 3x over xy times xy, times xy over y minus 4x. That allows us to cross cancel. The xy's cancel. And we're left with 2y plus 3x over y minus 4x. Number 7, we got 3 over x plus 5y. So the common denominator would be xy. Multiply left side by y, right side by x. And that would give me 3y plus 5x over xy. No factors, so that is it. Number 9, 2c minus 7 over 3 plus 4. Common denominator would be 3, so I need to multiply the right side by 3, numerator and denominator. So that gives me 2c minus 7 over 3 plus 12 over 3, which that gives you 2c plus 5 over 3. Number 11. What does that color scheme make you think of? Interesting. What'd you say? McDonald's, right? See, I just automatically jumped to McDonald's. It's incredible marketing to me. Oh, what are you talking about? Virginia Tech's like a maroon and an orange.
I don't know.
All right, shh. All right, quiet. The common denominator here would be 5y squared z. So I need to multiply the left side by z, right side by y, which would give us 12z minus 2y over 5y squared z.
We're so smart.
So there is a GCF there of 2 in the numerator. Took out the 2, but doesn't do anything, okay? You can't simplify it any further.
It's okay. We seriously did it. It's okay. Take that back.
Whoa.
Hello.
13, 2 over a plus 2 minus 3 over 2a. Our common denominator would be 2a times a plus 2. So I need to multiply the left side by 2a, the right side by a plus 2. So that'll give me 4a over 2a, a plus 2, minus
We didn't do that.
3a plus 6 over 2a, a plus 2. So again, remember when we're subtracting, to help prevent mistakes, we want to distribute that negative. So this will be 4a minus 3a minus 6 over 2a, a plus 2, which I would simplify to a minus 6 over 2a, a plus 2.
No.
15. 3 over w minus 3 minus 2 over w squared minus 9. Need to factor the denominator to get w plus 3, w minus 3. So I need to multiply the left side by w plus 3 to get a common denominator. All right, so left side in the numerator, I need to distribute that 3, which gives you 3w plus 9. That'll be minus 2 over the denominator, which gives you 3w plus 7 over the denominator.
I got it wrong because I can't do basic.
All right, number 17. We got k over k minus n minus k over n minus k. Well, if I rearrange the denominator on the second term, that would be negative k plus n. So the signs are opposite, right? So to get the same denominator, I'm going to multiply by negative 1,
We did that.
which that would give me k over k minus n. And then that would end up being plus k over k minus n, which would give you 2k over k minus n.
Look,
Wait,
look at
we
us
were
go.
opposite of it. No, we got it.
Get on 21.
19, 1 over x squared plus 2x plus 1 plus x over x plus 1. If we factor the denominator here, that would be x plus 1. Oop. X plus 1 times x plus 1. So I need to multiply the right side by x plus 1. And we distribute there. And that'll give me 1 plus x squared plus x over x plus 1 times x plus 1. So that numerator would be x squared plus x plus 1 over x plus 1 times x plus 1.
Oh, there we go.
21. We got n over n minus 3 plus 2n plus 2 over n squared minus 2n minus 3. So if I factor that, that would be n minus 3 times n plus 1. So I need to multiply the left side by n plus 1. So I'll distribute that, and that'll give me n squared plus n plus 2n plus 2 over n minus 3 n plus 1, which that is n squared plus 3n plus 2 over n minus 3 n plus 1. I can factor that numerator, can't I? What would that be?
N plus 2, N plus 1.
Good. Beautiful, Royce. N plus 2 times n plus 1 over n minus 3 times n plus 1. So what would cancel?
N plus 1.
N plus 1s. So my answer would just be n plus 2 over n minus 3. That was a fun one. I love that one.